Hey guys, alright, so as you're going to see later today with our video, we are going to work on making our own weather instruments, and we're going to set those outside. So you're also going to see that we have some weather charts available and a weather booklet. What we want you guys to do is we want you guys to help us track weather all week long. So submit your data to us, let us know what you think, help make some predictions, look at your local weather, write down what you think, and then write down what actually happened. And so at the end of the week, maybe we can go back and see versus the predicted and the real what actually happened with our weather. And were you right? Were you wrong? Did you have some right? And that's what all this is about. It's a learning experience for us all. We want to learn to be junior meteorologists, so we want to take this seriously, and we want to have fun, and we want to use our weather instruments, and we want to make the best predictions that we can, and then see how close we actually were. So it's okay to not get it 100% because we said meteorology was a guess, right? You have to learn, you have to study, and we haven't had years of training like a real meteorologist has. We are junior meteorologists, so it's okay to not have it 100% correct, and that's fine. We just want to get the best idea we can. So get a journal, get a whiteboard, get a corkboard, get a paper, whatever you need to do, and show us your weather stations. And every day, we want you to monitor those and let us know what you guys are seeing. Let us know if you have any questions. Thanks, guys.
Alright guys, thanks for joining us today for Would You Weather Day 2. Today we're going to be taking a look at meteorology. So what is meteorology? Well, it is a branch of science that studies the atmosphere, especially as a means of forecasting our weather. A meteorologist is someone who studies that weather, and they take a close look at many factors to determine what our weather will look like. Weather forecasting involves a combination of computer models, observations, and a knowledge of trends and patterns. By using these methods, reasonable, accurate forecasts can be made up to 7 days in advance. By studying meteorology, we can learn what type of weather might occur during certain parts of the year. We could learn to predict weather and what weather might be coming, or we could even learn how to predict how storms might move. Some forces we can study are earthquakes and severe storms. Severe storms can include anything from thunder and lightning to tornadoes and even hurricanes. It could also include other weather phenomena that might go along with it. Many of these forces can coincide. It is also important to note that these are not the only forces out there, but these are a few major ones that we observe and can learn from. Predicting the weather is a very difficult task. Meteorologists must study for many years and learn to use a variety of tools. A few tools can include thermometers, barometers, anemometers, and a weather vane. A thermometer is used to study temperature, a barometer used to study air pressure, an anemometer used to study wind speed, and a weather vane is used to study wind direction. They use these tools to measure atmospheric conditions that occurred in the past and in the present, and they apply this information to create educated guesses about what future weather may look like. The best we can do is observe past and present atmospheric patterns and data, and then apply this information to what we think will happen in the future. Meteorologists use the scientific method on a daily basis. Meteorologists also use satellites to observe cloud patterns around the world, as well as radar is used to measure precipitation or rainfall. All of this data is then plugged into supercomputers, which will use a numerical forecast equation to create forecast models of the atmosphere. These models can be both correct and incorrect, so a meteorologist must use all of their knowledge to create a determination of whether they agree with the model or not. If the meteorologist disagrees with the model, they then must determine a different outlook for their forecast. There are different models that can be used, so meteorologists will study the different ones and figure out which one they believe to be the most correct. So what are some things meteorologists can observe? A few we've talked about, things like our barometric pressure, temperature, wind speed, and direction, and even rainfall or the amount of precipitation we're getting. By looking at these things, as well as many other factors, meteorologists are able to study and learn about many of Earth's forces of nature. These forces can include severe thunderstorms, tornadoes, flash flooding, hail, hurricanes, tsunamis, and so many more. Today we're going to be just looking at a few ways that meteorologists use different tools to predict these and the certain storms we're going to be looking at. When we think of storms, we often just think of thunder, rain, and lightning. most people don't think about how severe these can actually be. We are going to be taking a look at the different ways storms can be considered a force of nature. A severe storm can include thunder, lightning, tornadoes, and even hurricanes. All of these storms can have a few similar factors that can include high winds, hail, and even flooding. High winds are caused by the sun warming the Earth's surface and the atmosphere. Hail is created when small water droplets are caught in the updraft of a thunderstorm. Flooding can occur during many storms. A flood results from days of heavy rain and or snow melting when rivers rise and go over their banks. A flash flood is sudden flooding that occurs when floodwaters rise rapidly with no warning and within several hours of an intense rain. They often occur after intense rainfall from very slow-moving thunderstorms. Lightning is an electrical current. Inside a thundercloud, many small pieces of ice bump into each other as they move around in the air. All of those collisions create an electrical charge, and after a while, the whole cloud fills up with electrical charges. The positive charges, or protons, form at the top of the cloud, and the negative charges, or electrons, form at the bottom of the cloud. Thunder is caused by lightning. When a lightning bolt travels from the cloud to the ground and it opens up a hole in the air, this is called a channel. Once then the light is gone, the air collapses back in on itself and creates a sound wave that we hear and call thunder. The reason we see lightning before we hear thunder is because light actually travels faster than the sound. Do you know how to tell approximately how far away a storm is? Well, there's a solution or an equation that we use. It's not exactly 100%, but it is a good way to get a general idea. So next time a thunderstorm happens in our area, take a listen and look out your window. Don't get too close and don't stand outside in it. But next time we have a thunderstorm, I want you to, when you see a flash of lightning, count the seconds between that lightning and the next time you hear thunder. And then you're going to divide that number by 5. So if we have a thunderstorm and it's 10 seconds between our lightning and our thunder, and we divided that by 5, 10 divided by 5 would be 2. So our storm would be roughly 2 miles away. So like I say, that is not 100%, but it is a good idea of something that we can get a rough estimate of how far our storm would be away. So we really need to take time to thank our meteorologists because they do so much to help us predict our weather, and they learn so much, and they help us to learn even more. So I want you guys to get ready, grab your tools, and let's...
Alright guys, so now we're going to start setting up our very own weather station. So you can email us, and we've got a weather book that you can use to track, and we have a weather chart that you can use to help track your weather. And then we are also going to help you guys by creating a chart every day. So we're going to note our date and time, what the forecast is supposed to be, what the temperature is supposed to be, is there going to be any clouds, how sunny is it going to be, what's the wind supposed to be, and how much rain or precipitation are we supposed to get. In order to measure these things, we have to have tools. So meteorologists, or the people who study weather, are using special tools. So we're going to make some of our homemade tools as well as trying to look at ones that scientists actually use. So the first one we are going to create is going to be our rain gauge. So for this, you're going to need some form of a bottle. It can be just about anything. You're going to need a marker, a ruler, and something to cut your bottle with. So we're going to start by cutting the top of our bottle off enough so that we can flip it upside down and use it as a funnel. Be very careful. You might want to get an adult help with this because we don't want anybody to get cut or anything. So we're going to start and just kind of work our way around the bottle, cutting that top off. sure we put all of our sharp items to the side so we don't cut ourselves. We have 2 parts of our bottle. Next thing you're going to do is take any tops off because we don't need that on there. And then we're going to take our ruler and we're going to measure up the side starting at 0, and we're going to mark inches. Okay, and then we're going to mark 1, 2, 3, 4, and my bottle can hold 5 inches. Gravel or concrete, you put a little stake or something to hold it down. And then you're also going to stick this in here. And it should sit pretty tight down in there so that our rain has to go through our funnel and not around the sides. And then every day you want to go out and check this so you would see, and you could use your ruler to measure. If it wasn't quite 1 inch, you could see if it was a 1/2 inch or 3/4 of an inch, you could use your ruler to measure that. Or we could see that it's anywhere between 1 and 5 inches. And that is our homemade rain gauge. The next thing we're going to talk about is making a weather vane. And a weather vane is something that helps us to determine which way the wind is blowing. So you're also probably going to need a compass or on your parents' phone. We're going to need a straw, a straight pin, some paper, and some scissors. So to start, we want to cut 2 triangles. So we have our 2 triangles here. And then in our straw, we want to hold it and make 2 slits. Make sure our slits are going in the same direction because this is where our paper is going to go in just a minute. All right, once we have our slits, we're going to take 1 triangle and put the top part of our triangle in the slit. This is going to create the tail of our weather vane. And our other triangle we're going to take and use the flat part in the other slit. And that will act like our pointing part of our weather vane. Okay? And then we're going to take our straight pin and we want to make sure that our arrow stays the right direction. So about center of your straw, we want to push through our straight pin, and you're going to want to wiggle it back and forth because you want this to be able to move freely and turn. So right now, I've really got to push it. So what we want to do is wiggle that pin back and forth until we create a bigger hole. So when your hole is big enough that it can move, you should be able to gently blow on the straw and it should turn. And then with your pen, you want to take and stick this in a pencil. We're also going to need a pencil. So once our straight pen is in there, you're going to take that pen and you're going to push it down in the eraser. Make sure to leave lots of room for our straw there. And then you're going to want to take your parent's cell phone or a real compass and you're going to want to figure out which way is north. So for me, where I'm at, alright, so where I'm at, exact north for me is pointing that way. So when you're outside and your wind starts to blow, your weather vane is going to point to wherever the wind is blowing. So you're going to want to turn the compass exactly facing where the arrow point is pointing, and that will tell you which way the wind is blowing. And our directions are north, south, east, and west. Those are the main cardinal directions. There are a few like northeast, southeast, things like that. But mostly we're just going to focus on north, south, east, and west. So that is our lovely DIY weather vane we're going to put to the side and use for our weather observations. So the next thing we're going to do is make what's called an anemometer. An anemometer can help to measure wind speed. So for that, you're going to need 5 of these little paper cups, some duct tape, wooden dowels, and some hole punch and scissors. So we're going to start by putting holes on the sides of our paper cups. Just one side for now. So we're going to go down and put in a hole. We're going to do this only on 4 of our 5 paper cups for right now. Okay, don't get rid of your hole punch just yet. We're going to need it again for our last cup. But this cup, we're going to put 4 holes evenly spaced around the rim. So across and across. So we're going to hold it still. There's 1, 2, 3, and 4. There's our holes. All right, we're going to take 2 of our wooden dowels and we're going to crisscross them in the cup we just put 4 holes into. Try to space them as evenly as possible. And you want to create an X. So if we look inside of our cup, you should be able to see our X or our cross, however you want to look at it, and that's what the inside of our cup should look like currently. So we want to make sure we're putting our cups on our anemometer. It's going to sit like this, so you're going to want to tilt the cups to one side, make sure they all face in the same direction, and we're going to tape these on so we know that they always stand still. Okay, so our next cup we're going to put on, we're going to do the same thing. Okay, continue on around to our next cup. Make sure we have some good tape. All right, and our last cup. All right, so now we have our cups all facing the same direction on our anemometer. All right, and last we're gonna take our scissors, or I can use our little X-Acto knife, and we're gonna make a small hole in the center of the bottom cup. This hole is gonna be for our last dowel. We're gonna stick it up through here. Just like that. And we're going to take just a little bit more tape, and we're going to tape that bottom dowel to our dowels in the middle that make that X. All right, so we got everything taped up. You may have to fix some of your straws here. Use a little more tape so that they stay facing the right direction. So all of our cups are now on our anemometer, and you can see all of them are facing the same way. Now you would want to take this and stick it in an empty water bottle, okay? Once you got that in there, then your parents are gonna have to help you with this next portion, okay? So, with an anemometer, we said that they measure wind speed. Well, if we just twirl it with our hand, is that gonna give us an accurate measurement of wind? Probably not, okay? So what you need to do, this is where we're gonna have to have our adults, you're gonna take this, once it's in your empty water bottle, and you're gonna have an adult drive down the street, driving exactly 10 miles per hour. Hold the anemometer out of the window and count the number of rotations, so how many times it spins. Maybe you need to mark a certain cup with a black marker or something, and so you count 1, 2, 3, etc., okay? And you're gonna do that, how many rotations happens in 30 seconds? For example, if your anemometer spins 10 times in 30 seconds on your 10-mile-an-hour test run, then you know in the future 10 spins in 30 seconds means the wind is going approximately 10 miles per hour. If you want to be even more accurate, you can calibrate at many different speeds. So you could try it 20 miles an hour, 30 miles an hour. You probably don't want to get much faster than that because we don't want it to blow off into the road because we don't want to litter. But try it at different speeds and see how many you get, and that will help to even better calibrate your anemometer and give you a better idea of how many spins equals a wind speed. All right, guys, so make sure to record your results every single day and give us some of those data that you guys collect.